We're in the home stretch. Let's get these last problems solved and be ready for class on Thursday. How many ways can 24 students be assigned to 5 advisors? You have to look at this problem the right way in order to find the easier solution. The students themselves are distinct entities, but the advisors can be repeated. So I like to think of the students as essentially standing in a line at the registrar's office waiting to get their advisor's name. So for each student in that line, they have 5 choices of advisors. So the answer is going to be 5 times 5 times 5, 24 times. You can think of this as a permutation with infinite repetition numbers. Problem 2. You have 10 coins in your pocket. They're only nickels, dimes, and quarters. How many different combinations of coins are there for the money in your pocket? This is another one of those stars and bars examples where the varieties represent the denominations of the coins: 5 cents, 10 cents, 25 cents. We have 3 varieties, and the objects, the number of objects we're selecting, are the number of coins in your pocket. So we were told that there were 10 coins. So there are going to be 10 bars, or ones, and 2 pluses to divide the 3 varieties. So this is an example of a combination with infinite repetition numbers, but we're going to solve it by thinking of it through the stars and bars argument, which ends up being a permutation of finite repetition numbers. So it's hard sometimes to just put a single label on it. So here we have 10 coins, which are representing the objects, and we have 3 varieties, which are the nickels, dimes, and quarters. So we're going to distribute the 10 ones and 2 plus signs to give us an ordered permutation with finite repetitions. And we know in this particular case that's a binomial coefficient, 10 objects, 2 dividers. So 10 plus 2 is 12. Choose 10. And finally, how many solutions are there for x1 plus x2 plus x3 equals 17 if x1, x2, and x3 all have to be positive? I'm going to do this on the next page. This is actually very similar to the previous problem. We can think about distributing 17 ones into the 3 boxes, where somehow we have x1 is one of our boxes, x2 is one of our boxes, and x3 is one of our boxes, and the total number of ones in each box represents the integer. What makes this different is the restriction that x1 plus x2 plus x3 all have to be positive integers. That means they have to be greater than or equal to 1. So let's just make it happen by putting a 1 in each box. There's only one way to do that. That's not going to add any options in terms of how we fill the boxes. But if we put 3 ones in the boxes, 1 in each, that means there are 14 ones that remain to sort of be freely distributed between the three varieties. So if we're going to distribute 14 ones to 3 boxes, you're going to take an arrangement of 14 ones and 2 pluses. So that's going to be 16 objects that are being arranged, and you select where the 14 ones go, and that gives you an answer of 16. Choose 14. Keep up the good work, and I'll see you on Thursday.